Good evening everyone. In this video we will be talking about application class model and application state model. So once you are ready with this sort of application interaction model, you have to think about application class model. Application classes actually define the application itself rather than the real world objects that the applications act on. The real world objects are the ones which are actually defined in this sort of domain analysis. The domain class model basically consists of those things already. But the application classes are in addition to that one. They actually define this sort of application itself. Most application classes are computer oriented and define the way that users actually perceive the applications. So again, for constructing this sort of application class models, okay, you should always start with this sort of specify user interfaces. If it is an ATM, how am I interacting with that one? What are the user interface for that one? So a user interface is an object or a group of objects from it. Okay. So provides a way to access the system's domain objects. The domain objects are the ones which are actually hidden from you. Indirectly you are actually trying to interact with them. Isn't it? So these sort of user interfaces actually provide you a way to access those domain objects. And of course all the commands and everything, and also like the other application options. Okay. Try to determine the commands that the user can perform. Okay, so in this step. So once you basically have this sort of user interfaces, try to determine like the commands that the user can perform. A command is a large scale request for a service. Okay. Say for example, like make a flight reservation. Okay, so that requires a lot of other steps. Okay, so it is a large scale request for a service. Similarly, like finding matches for a phrase in a database. So that's also a, like it's a big service on its own. But for all these things, like you can actually start with some sort of simple sketch, okay, a sample interface, to basically help in visualizing the operations of an application. Okay. So by visualizing such a thing, we can actually identify if anything important is actually forgotten. Of course, if you basically want to have this sort of sample interface and then like you want to simulate the complete execution, you need to put some sort of dummy procedures for executing the actual business logic or application logic in the background. Say for example, if you want to execute the transaction and then like it basically has to go to the bank and then like verify all the things and then like check it and then like commit the transaction and then like deliver the money to the user. When we are trying to design the user interface, you will not be worried about all the things. You will be basically putting a dummy procedure for that one. So once you enter all the details and then like if you want to approve or something, okay, you got the details. The dummy procedure can just say like, yeah, okay, it is approved. Okay. So when you are trying to think in terms of user interfaces, you can basically sketch these sort of simple interfaces, sample interfaces. So once you have this one, you have to define the boundary classes. A boundary class actually provides a staging area for communication between a system and an external source. Say for example, when you are trying to develop a domain model, okay, a class and all these things, it can actually interact with external systems. Okay, so the basic domain model can actually, I mean like the core system can actually interact with external sources. But the thing is like the external sources should not be defining like what is the structure of your system. Say for example, how you will be interacting with an ATM should not be defining like how you will be defining your bank account. Your bank account and then like its static features, they are standard. Okay, how the ATM interacts with that bank account, it's a different aspect. For that sort of interactions, like you need this sort of boundary classes. These boundary classes actually understands the format of one or more external sources and converts the information for transmission to and from the internal systems. Say for example, if an ATM is trying to interact with the bank class, it will have a boundary class using which like it will try to interact. Say for example, account boundary. If it wants to interact with that particular account, user's account, it will have a boundary class. okay, to encapsulate this sort of communication between the ATM and the consortium. These boundary classes are in general are used to model this sort of interaction between the system and its actors. Okay, so these are again new classes which are coming into our analysis. Okay, through the application analysis. First, you have identified some classes by defining these sort of user interfaces. Then you have defined these boundary classes. Then the next bunch of classes actually come from this sort of determining these sort of controllers. Controller is an active object that actually manages control within an application. Control classes are generally used to represent coordination, sequencing, the whole transaction, and the control of other objects, etc. Control classes can be used for that. They are often used to basically encapsulate control related to a specific use case, one specific use case. So the controller actually receives the signal from the outside world, okay, or from the objects within the system. And once it basically has this sort of signal, it basically reacts to that. And it then basically invokes certain operations on the objects within the system. And the systems to the external or to the outside world. So a single class, okay, so this controller class may be actually doing all these things, interacting with all these different objects within the system. Because the point is like within the system, you do not want to give access to each and every object which is like there. Then, I mean, like it cannot scale well, and it will also have a lot of security issues. So that means like you will always have some sort of these control classes and boundary classes using which like you will be interacting with the system actually. So most applications at heart have one or more controllers that actually sequence the behavior of the application. It is a very common phenomenon actually. So you will have this sort of controllers, very common. In ATM, one control loop actually verifies these customers and accounts. Okay. Say for example, one single control loop can actually check all this sort of verifies the customers whether he is a valid customer. Okay, and then like he will also check this sort of accounts and everything, and then like it basically returns the control to the user, isn't it? When you enter the PIN number and then like you are trying to initiate a transaction, and actually all these things are verified in the background. Okay, that's about the control loop. Once you have this sort of basic application class model ready, you have to check it against interaction model. The interaction model which you have defined just now, okay, before this one, okay. So the application interaction model, you have to actually check against this one. Go over the use cases and think about how they actually would work. Okay, that's what like you have defined this sort of application classes, but then like again you actually check like how the use cases would work. When the domain and application class models are in place, you should be able to simulate a complete use case with the classes, because now you both have the domain class model and you already have this sort of application class model. In conception, like if both of them are complete, you have everything there. Literally all your classes are there. So if I give you a use case, okay, you should be able to simulate how you will execute that use case, or like how you can actually simulate the use case with all the classes with it. Of course, like as far as the operations and all these things, like you can still have these sort of dummy implementations, but you should be able to simulate once you have this sort of application class model is ready, and you already have the domain class model because domain analysis is already done. So that's about this sort of application class model. Once you have this sort of application class model, you need to develop this sort of application state model. The application state model, okay, so when we were discussing about these even domain class models and then like the domain state model, we have discussed like, so basically like in the state model, like you will take each and every class that has some sort of temporal behavior, and for that one like you will be actually defining all these sort of states. Now when you are thinking in terms of application state model, the application state model actually focuses on application classes. The domain state model focuses on domain classes. Now the application state model focuses on application classes. So in that sense, like basically like this application state model augments to this sort of domain state model. So it adds additional information to that. So again, the steps for constructing this sort of application model are something like this one. First, we have to actually determine the application classes with states. Okay, that is the first thing which you have to do whenever you are trying to define a state model, for which of the classes you will be doing. So that is what we have to define. So good candidates for state models are actually user interface classes and the control classes, which we have discussed them when we were actually developing that sort of application class models. Okay, so the user interface classes and then like these control classes, they will have several states. So for them, like you basically start with. Once you have identified these classes, you first have to identify the events. This is a difference in this sort of application state model. So we have to first find the events, not the states. Remember this. So for identifying the events, study different scenarios, and then like you actually extract all the events. So earlier, like in one of the diagram, like I have shown you like a lot of events which are possible in this sort of ATM example. As I already mentioned, like in domain model, you first find the states, and then like you will try to find the events. Whereas when you come to this sort of application state model, okay, you first find the events and then you actually find the states. That's the difference between these two state models. Okay, in designing these state models. Say for example, like some of these events, the way like I have given you huge number of events. So some of these events can be like insert card, enter password, end session and take card. Based on these events, okay, the classes actually may have different states. Okay. So once you have these events, you need to basically build these sort of state diagrams. How do you actually build a state diagram? You have to build a state diagram for each and every application class with a temporal behavior. That is very clear for us. Okay, that's what these are the classes which we have identified in step 1. For the initial state diagram, okay, say for example, you have taken a class and you want to draw an initial state diagram for that one. You have in the interaction model like a lot of sequence diagrams. Take a sequence diagram where one of these object is actually participating. So if you are trying to talk about an application class, see where its object is participating in any of the sequence diagram. Okay, where the object is participating, and basically like you actually extract those events from there. So with which of the events like if this object is actually interacting in the sequence diagram. Okay, so all the events which are coming in and all the events which are going out, and from there like you actually define the states. Okay, so in that sense, like every scenario or sequence diagram actually corresponds to a path through the state diagram. Okay, so every scenario and sequence diagram. Okay, so whatever you have in your interaction model actually corresponds to a path through the state diagram. I mean, like the way like those objects are interacting, that object will be in different states here in this particular state model is concerned. The state diagram for that particular class is concerned. Of course, we also have to find any loops. Say, for example, if a sequence of events can be repeated indefinitely, then they form a loop. So then, like if it is a state diagram, like you will be there infinite. So that means like there will be some terminating condition. There will be at least one event which will be taking it to the end, etc. You have to think about all. Of course, like it all depends on the application. Earlier, we also have seen the cases where like there will be infinite loops. Okay. Say for example, like when we are talking about the state diagrams, we have seen that traffic state diagram. It will never tell. It will basically like the lights will be going on red, light, green. Okay, red, green, yellow. Okay, so basically like across the continents. So that will be an infinite loop. If you are designing an application for that one, you don't basically worry about that. Okay, but even for any other application, even for the games like what we have seen, like eventually it has to end. Okay. So once you basically have taken this one of these sort of sequence diagram, and you have put all its events, and then like you have identified the states. Okay, so you have the preliminary state diagram, but then like you have several other sequence diagrams in which like these objects of that particular class, that particular application class are interacting. So take each and every sequence diagram and try to merge those things into the state diagram, all those events and everything. Once you have identified all the normal events, okay, normal events have been considered as variations, exceptions, cases, etc. Everything. And that's how like the basic state diagram basically grows. Okay. You start with a basic state diagram by looking at the primary events in one of the sequence diagram. But then like you will iterate through all these sequence diagrams and you will be identifying these new events and new states, etc. And then like that's how like the state diagram basically grows. So eventually the state diagram of the class is finished when the diagram covers all the scenarios. That means like all the sequence diagrams. And the diagram actually handles all the events that can affect the state. Okay. So it's a reasonably long procedure for that one. Building the state diagrams for that particular process. You should be basically identifying all the events for that. Once you have this sort of application state model ready, check against the other state diagrams as well. Of course, like you have designed the state diagram for one application class. Okay. So then like design the state diagrams for every other class for which like it is actually interesting. It has a temporal behavior, okay, which we have discussed in the earlier videos. Okay. And then like we also have to remember like every event should have a sender and a receiver. Okay. Follow the effects of an input event from the object to object to the system to make sure that they actually match the scenarios. They should match the scenarios. And we also have to make sure that the corresponding events on different state diagrams are actually consistent. Okay. And also like so you will be checking like how the different state diagrams will interact, etc. Okay. Say for example in ATM, the session controller, okay, initiates the transaction controller. So one object is actually initiating the object. So how the states are basically going on. Say for example, if the transaction controller is actually coming to the finished state, what will happen to the session? So you need to have, you should be thinking about all these things. Okay. So even the different state diagrams will also have to each other. Once you have this sort of application state model ready, you have to check against this sort of class model. Multiple ATMs can potentially concurrently access to an account. For an account, like you can have ATM cards, pretty much possible. If it is a family account, the husband will have a card and then like the wife will have a card. Assume like exactly at the same time, like they are in the two different ATM centers and then like they are actually inserting the card and trying to draw some money out of the account. Then the account actually needs to be account access needs to be controlled to ensure that only one update at a time is updated. So this is about the database transactions again. Okay. And if your application basically allows that one, you have to go to the class model and then see that, ensure that particular class model in that particular operation. Say for example, like the update transaction or like the transaction execution method, whatever it is there, it should be synchronized. So that means like only one of them can actually access that method. So you basically have to ensure those things. Again, that is very important. Of course, once you have this sort of application state model, okay, we have to check against the interaction model. Check the state model against the scenarios of the interaction model. Okay. We have to simulate each and every behavior sequence by hand and verify the state diagrams, whether it is actually moving to the exact state the way you are expecting, or like if there are any deadlocks and then you are stopping anywhere, if there are any loops, or like if there are any states which are missing, or like any events which are missing. So you should go back and check again this sort of interactions again. So basically, like take the state model and trace out the legitimate paths for each and every sequence diagram, etc. Okay. So these are the things which are to be taken care once the basic application state model is constructed. So that's about like how we can construct this sort of application interaction models, application class models, and application state models. One thing we have not given that much of importance, especially in this sort of domain analysis and application analysis as of now, is like we have not focused that much at the operations. We mostly dealt with defining the classes and then like defining these sort of attributes for them. Operations we have not talked much. Okay. So now once during the analysis, application analysis, you will be also taking care of these sort of operations. For the domain analysis, like operations may not be that much important. Okay, but for the application analysis, operations are very important. So you will be adding these operations, especially from the class model. You can put about all these operations like reading and writing of attribute values and association links. These things you can actually put. Okay. Of course, you need not have to show all of them explicitly, but then like you will have some operations there. And you will also have some operations from the use cases, especially this is very important. Use cases actually lead to several activities. Okay, so from the use cases, like we have even seen the activity types. So all these activities actually correspond to operations on the class model. So once you start analyzing these sort of operations and then like these sort of activities in the use cases, you will be defining these operations for these respective classes. Say for example, verifying the cache card, that will be an operation. That's an event or an activity for that particular use case, and that eventually becomes an operation for that particular class. And there are also like these shopping list operations. So they are called actually shopping list operations. The real world behavior of a class actually suggests these operations. Something like, say for example, if you are creating an account, you should be closing that one as well. Say for example, if you want to create a savings account for a particular customer. Okay, so these are different sort of operations. These are called shopping list operations. Provide an opportunity to broaden the class. Once you have the basic operations, you should be simplifying the operations. Try to broaden the definition of an operation to encompass similar operations. Because you don't want to have too many operations. Okay? So you can use inheritance to reduce the number of distinct operations as well. So you should be taking care of all these things. Okay, so these are the optimizations. So with that one, like you will have your basic application analysis models will be ready. Okay, but then like iterating is a fundamental principle of the analysis. We already have talked about it during the domain analysis. Let me reiterate again. Most analysis models actually require more than one pass to complete. Okay. To understand the problem with all its implications, you must address analysis iteratively. First, you will start with a first approximation to the model, and then like you will actually iterate and refine the analysis model as your understanding basically increases. So whatever the first model like which you have developed, it is not the final one. You have to iterate, and you will keep on refining the things. But the catch with that one is there is a tendency for the models to basically grow as analysis proceeds. So amount of development work actually escalates as the model becomes larger in size. So in the iterations, you also have to take a closer look at the model. For minor concepts to come are like additional abstractions that can actually simplify the model. See, you want to incorporate everything into the model, but at the same time, like you would like to see that the model is simple enough. Okay, so that's how like you are actually trying to refine the analysis model. So then once the analysis is actually complete, the model actually serves a basis for the requirements. Why you are actually doing all the modeling and everything? You want to capture each and every requirement, how the system behaves, how the system actually works, how the user actually interacts. Okay, what is your domain model, domain class model, and everything. Once you have the analysis is complete, the model more or less serves as a basis for the requirements. That means that most requirements will be part of the model. So if all the requirements are in the model, that would be an ideal thing for you to basically verify with the requester. Say for example, somebody asks you to basically, your client actually wants you to develop that application. So once you have the model ready, that means like you have captured all the requirements. So it is better idea to basically go and check with the requester whether everything is there or not. But at the same time, like, during the analysis, some requirements may actually appear to be incorrect or impractical. Okay. So this is the time like you can actually go back and confirm the corrections to the requirements. So you can go back to the client and basically you can actually get the clarifications right. Okay. That means like you may even go back to the system conception stage again. See, that's how like it is an iterative process. Regularly going back across the different steps. Okay. And you will be regularly improving the model. So you have to interact with this sort of business and domain experts to make sure the analysis model correctly models the real world. Okay. So this is here we are talking about both the domain analysis and application analysis. Once the domain analysis, application analysis are done, you had all the requirements. Okay, and then like you basically would like to interact with these business and domain experts to make sure the analysis model is complete and it is done. In fact, actually, analysis models are effective means of communication with business experts. Because keep this in mind, probably most of the business experts are not computers. And models are very easy way to communicate with these sort of business experts. So regarding the references are concerned, it is an excerpt from chapter 13 of Object-Oriented Modeling and Design with UML, second edition, Michael Blaha and James Woodward. Thank you very much for your attention.